There, this is Anastasio G. Pantaleon Jr. and welcome to my YouTube channel. In today's video, we will be dealing with constant volume mixture problem with decreasing concentration, an application of the first order differential equation. So first, we have to understand the key concepts or key principles of mixture problems. In these problems, we will start with a substance that is dissolved in a liquid. Liquid will be entering and leaving a holding tank. A liquid or the liquid entering the tank may or may not contain more of the substance dissolved in it. Liquid leaving the tank will of course contain the substance dissolved in it. If the concentration of Y or any substance at a function of time gives the amount of the substance dissolved in a liquid in a tank at any time t, we want to develop a differential equation of that. When solved, will give us an expression of y or substance dissolved to the function of t. So the main assumption that we will be using here is that concentration of substance in the liquid is uniform throughout the tank. The main equation that we'll be using to the model this situation is dy over dt is equals to the rate in minus the rate out. So let's start with a problem. So you're given a problem. A tank initially contains 100 liters or 1000 liters of water with 15 kilograms dissolved salt and at a constant mixing to ensure uniform concentration. Fresh water enters at a rate of 15 liters per minute, while the tank drains also at 15 liters per minute. So what do you mean by this is that we have a constant volume problem. So the main problem is that how much salt in the water tank after 10 minutes. Those we write are main equation. So dy over dt is equals to rate in minus rate out. Also, given in the condition is that at time 0, y is equals to 15 kilograms of dissolved salt. So we need to find the function of y with the time t. And afterwards, we have to find y to the 10 minutes. Okay. How much salt in the tank after 10 minutes? So we have to determine first our rate in. Of course, if this is the tank, okay, it has a rate in of, say, how much is that? 15 liters per minute, but zero salt because we are dealing with only fresh water. Okay, and in the tank we have a concentration of a brine because we are initially having a salt and a water, so it's a brine already, and we have an out of 15 liters, and of course there are salts dissolved in it, so the salt has been decreasing after some time, and we have to find it at a certain time. Okay, let me complete this. Okay. So therefore, your rate in is 15 liters per minute multiplied by 0 kilograms per liter. So you have to cancel that, a liter and 0. So therefore, your rate in is 0 kilograms per minute. Now comes your rate out. Okay, rate out is equals to y at a function of time over 1000 liters. So that means they have at a certain time, okay, we have in kilograms per liter. This means that your concentration of salt is dependent on the time that your water or your brine uh, is giving out. Okay, so this we have to multiply that in 10 liters per minute. Okay, so we have like that. So the function of your rate out is equals to y to the function of time per 100. Okay, so like that. We have to erase that. So this is in kilograms per minute. So we have to divide a line on that. Okay, so this means that dy over dt is just equal to 0. Your input, your output is minus y to the function of time over 100. Take note, okay, this is just a function of time and not a multiplication of time. Okay, take note of that. And of course, you must have to say be consistent with the units. So if we mean kilograms per minute, that will be kilograms per minute all throughout. And be careful, you might have to convert that some of the units into minute if it is given in seconds. Okay, so this one becomes dy over dt is equals to negative y to the function of time over 100. Okay, we take note that this is not a multiplication but rather y to the function of time. Okay, so we integrate. I know, not yet. So we have to separate variables. So this becomes dy over y is equals to negative dt over 100. And we integrate that. So we have integral of dy over y, which is equals to negative 100 integral of dt. Okay. You might be confused. We let out of the time because we all mean that y is just a function of time. So this means that in this corner, we have the y to the function of time. Okay? So we have ln y is just equal to negative t over 100. So we only want the y. Y is equals to, okay, I forgot we have to add c here. constant, E negative T over 100 plus C, or Y is equals to E to the C multiplied by E to the negative T over 100. E to the Z will just be equal to C. So that means your Y, okay, to the function of time is just equal to C to the E negative T over 100. As we notice here, Y to the function of T is just this one, the expression. Okay, we have the function of T. Take note of that. So initially, at Y to the time 0, which has the term initially, be careful with the initially term. Initially, this means that at time is 0, we have 15 kilograms of salt dissolved. So that means, okay, at Y is equals to 0, we have 15 kilograms. Is just equal to the C, E to the negative 0, 100. So E to the 0 is 0 divided by 100 is 0. E to the 0 is just equals to 1. So your C is equals to, your C is equals to 15. Okay? So therefore, at what is the salt concentration of the tank after 10 minutes? So Y to the 10 is equals to 15 E to the negative 10 over 100. Okay, so we have, how much is this?